learn about the more series creation methods. In previous module, we have covered the series creation with the help of list as well as with the help of dictionary. Now I am creating the series with the help of a scalar value. For this, I am using the function again pd.series and passing here a singular value, a single value that is called scalar value. I am passing here 5 and the index I have given is 0, 1, 2, 3 as you can see in the slide. Now I am passing 5 as the scalar value and index is 0, 1, 2, 3. And if I am printing this series, we will get 0, 1, 2, 3 as the index part and 5 as my data part. Clear? Here 5 value will repeat 4 times because I have given 4 indexes. So this is the method to create a series by repeating any scalar value. Clear? And d type of the series by default is integer 64 because I am using the non-fractional values here. Clear? You can write any value here in place of 5. If you want to repeat any string value, text value, or you want to repeat any decimal value, you have to write here the value and then pass the index. Clear? Next slide I am going on. Now we will learn about the arithmetic or mathematical operations with series object. Arithmetic operations are the mathematical operation like addition, multiplication, division and subtraction. Okay? If we add two series, if we multiply two series, if we divide two series, then what will be the rule for these type of calculations? So you can see the definition. Arithmetic operation like addition, subtraction, division, etc. with two series objects. The operation is performed only on the matching indexes, not on the non-matching indexes. If in two series some indexes are non-matching, then NaN will be shown in place of that. Clear? In this example, I am taking two series. First series is S and second series is T. You can see the first series contain the data pd.series 1 to 3. Data is 1 to 3 and second series T contain the data 1 to 4. If I am adding this series S plus T, I am taking the operation addition. It means both the series add together and we get the values 0 index 2, 1 index 4 and 2 index 7. How you are getting these values? You can see in the first series at the 0 index what we have 1. Clear? And in the second series T we again have 1. 1 plus 1 is 2 and 2 plus 2, both the series on the 1 index have 2 value. It means 2 plus 2 4 and this value I have 7 value I get with the help of 3 plus 4 because this series contain 3 value at the 2 index and this contain 4 value at the 2 index. It means all the indexes are matching indexes. It means no NaN will appear here. If I am multiplying two series, how you will get the answer? 1 cross 1, 1 into 1, 1, 2 into 2, 4 and 3 into 4, 12. It means all the index are matching, so multiplication take place and no NaN you will get. Clear? Now next slide which I am covering, it contains the series, it contains an example. Here I have used some non-matching indexes. Clear? See, ARR is an array and P dot array, it contains the value 3.5, 14.75, 26, 37.25, 48.5. Clear? I have used a list ABCDE. I have created a series S1 PD.series, data passed as array and index I have taken as ABCDE and second index I have created with the help of range function or range function and index I have taken A, B, 1, 2, 3. Now you can see that in both the series some of the indexes are non-matched. Clear? In this series we have CDE and in this series we have 1 2 3. It means these are my non-matching indexes, and these A B are my, these A and B are my, these are my matching indexes. Clear? A and B. It means when I am doing the mathematical operation addition, what will happen? Only A and B index value will be created with the help of addition operation. Like A index have 3.5 value in series S1, and in series S2 we have at the A index, which value we have? We have 1 value. Clear? So it means because I am using a range function, so we have a series with value 1 2 3 4 5. Clear? It means 3.5 plus 1 we get 4.5, and at the B index we have 14 plus, in S2 series we have 2 value. Clear? So what we get? Sorry, we have 14.75 plus 2, we get 16.75. Clear? And all other indexes are non-matched. 1 2 3 C D E, all are getting the NaN value. Clear to all of you the concept of addition with non-matching indexes? Clear? Next is head function. Head function is used to display first 5 values by default, or you can pass the parameter. In head function we can pass parameter, or we can left the brackets empty, no parameter. If I pass, if I am saying here s dot head, s dot head, head means top of the series. Clear? If I am writing here blank bracket s dot head, it means first 5 indexes you will get with data. If I am passing the parameter here s dot head 3, it means I will get only 3 indexes with data from the series. I have given here s dot head 3, it means I am getting only 3 index with data. Clear? Suppose we have a series with many values, like we have 100 of values, and why I want to display only first 10 index, then you can use s dot head bracket 10. Clear? And if you are passing the empty bracket, it means by default you will get first 5 data for the series. Clear? Function is tail function. This function is used to display last indexes from the series. Like if I want to display the last 3 index from my series object, then I will write s dot tail 3. I can use the tail function without parameter also. If I skip this parameter and write here only blank bracket, empty bracket, then by default it display 5 indexes. Last 5 index it will display. Okay? It means passing the parameter in tail function is not mandatory. Okay? As in head function, if we are specifying s dot head blank bracket, you will get first 5 index, and if I am writing s dot tail blank bracket, I will get last 5 index. Okay? And if I will specify the value here, then it means you are getting that number of indexes from the last position. Okay? This is my tail function. Next function is, if I want to specify, if we want to get any particular index value, I can use here s square bracket 0. It will display the 0 index position value. Now you can see that what is this position, index position. We have given the index A, B, C, D, E. Now what is this index position? In series, if I have given the index, then A, B, C, D, E. I have 5 index, value is 1, 2, 3, 4, 5. These are my index. Clear? And if I am saying what is the position of this index, position is 0, 1, 2, 3, 4. Clear? Every index has a default position, and that is always start from 0. Clear? This is my position. Index I have given as A, B, C, D, E. If I am specifying here S0, it means what I am displaying? I am displaying the 0th position index value. Clear? And it means I will getting the output 1. Clear? I can use S colon 3. S colon 3 is same as slicing we have covered in the numpy array or in the string. If I am writing here colon 3, it means 0, 1, 2 position will be displayed. Clear? 0, 1, 2. This is my 0 position, this is my 1 position, this is my 2 position. Clear? If I am writing as minus 3 column, it means I am using here the backward index also. You all know that what are the backward index? Minus 1, minus 2. These also you have covered in numpy array or in list. Minus 1, minus 2, minus 3, minus 4. Clear? It means writing S minus 3 column, what will be displayed? Minus 3 column means minus 3 position is C index. It means 3, 4, 5 will be displayed. If I am using negative index, it means negative index means I am using backward index. Clear? This way we can get the particular subset of my series. Next is retrieving data using label as index. If I want to display the data using label, like here I have given the label index as A, B, C, D, E. I want to display the C and D index value. So then I can write S square bracket, then again put a square bracket and write here the subset C and D, C colon C comma D. So you will get the CD index value. Okay. Next is Pandas series retrieving data from selection. If you want to get the selection of a particular index, we also have two more methods. One is LOC and another is ILOC. LOC is used for LOC stands for locate and ILOC integer location. Okay, integer location. I am locating the values with the help of integer location. I stands for index location we can say or integer location we can say. LOC get rows with particular labels from the index and ILOC get at a particular position in the index. It means LOC I will use when we have given the label as index like A, B, C, D, E I have chosen as the index, and ILOC I will use when we have the integer position, integer index. Okay? Suppose I have not taken the A, B, C, D, E and by default the indexes are 0, 1, 2, 3, 4. You can use ILOC, and if you have chosen the A, B, C, D, E and I am using the ILOC, it means it will work on the particular position of the index. Clear? See in examples. In this example, I have taken a series spd.series np.nan. Index are 49, 48, 47, 46, 45, 1, 2, 3, 4, 5. Clear? It means value I have used as data I have used as np.nan, means all the values are nan, and index I have chosen 49, 48 and so on like this. If I am using s.iloc colon 3, iloc means as we have studied in previous slide, integer location I am using 0 colon 3, it means it work on the position 0, 1, 2. 0, 1, 2 position is 49, 48, 47. It means you will get the output 49, 48, 47. This is my 0, 1, 2 position. Clear? And if I am using s.loc colon 3, s.loc colon 3, it means 0, 1, 2, 3 position. Okay? Slice up to and including the label 3. When I am using LOC, then the label 3 also included. Clear? This work on label as well as work on position. Clear? But ILOC work on only on the integer location or integer index or positions. Clear? If I'm using s dot loc column 3, it means slice up to and including label 3. It means 49, 48, 47, 46, 45, 1, 2, 3. Clear? You can see from here we have up to 3 are the labels. These are the indexes. It means up to 3 I will get. In LOC, the last value is included. Column 3, if I am writing, it means from starting to third starting to third index in my series. Okay, it doesn't work like 0 1 2. Okay, next is modifying element of the series object. Next method is how to update or modify the any particular series element. We have a series here, pd dot series range 1 comma 15 comma 3, and index I have taken as, you can take the index like this, x for x in a b c d e. It means x value of x is, I have used here for loop. I can use the for loop here as like this also. For loop work on the string, and x value will be a b c d e. Okay? It means 1 15 3 1. Step value is 3 here. Step value is 3. This is my start. This is my stop. It means I will get 1, 1 plus 3, 4, 4 plus 3, 7, 7 plus 3, 10, 10 plus 3, 13. Stop value is 15. It means I will stop at 13 because 13 plus 3 is 16 and 16 I cannot take. And what are the index? A, B, C, D, E. Clear? These are taken from this loop. Now, if I want to change the C index value, then I will write S1 C equal to 90. It means C index value in place of 7, now I will get the value 90. You can see from here, this is my output after updating the series. Okay, this way you can update the series element. Next is modifying series object using slice. You can modify the series object as by giving the slice also. If I am using a series object start colon stop colon step equal to new value, it means whatever value fall in this slice, all will replaced with this new value. Okay, just a minute. This way you can update with the help of slice. Okay, start colon stop colon step. Okay, if I'm writing here 1 colon 1 colon 4, 1 colon 4, it means, and equal to 1 colon 4 equal to 10. It means which slice will be affected? 1 index, 2 index, 3 index, and all will be updated with the new value 10. Okay? Next is vector operation on the series object. Vector operation means if you apply a function or expression, then it is individually applied on each item of the object. If I am writing s plus 2, it means all the series element will be increased by 2. If I am writing s star 3, it means I am multiplying each and every element of the series with 3. If I am writing s star star 2, it means power 2, and I am assigning the new series to S1 object. S greater than 15, it means I am checking that all the elements are greater than 15 or not, and I am getting the answer in true or false. Okay? These are my vectorized operation. Next is series object attributes. Series object attributes mean we have different attributes, like I can use with the series s1 dot index. S1 dot index means I am displaying the index part of the series. If I have taken the series 3.5, 14.75, 26.00 like this, and these are the index A, B, C, D, E. I want to display only the index, then I will use the attribute s dot index. Okay, s1 dot index. Next attribute is s1 dot values. This will display the values part. Okay, this is my values part. This is my index part. If I want to display index, I will use index. If I want to display values, then I will use s1 dot values. If I want to display the data type, then I will use s1 dot d type. And what is the d type for this? Because I am using decimal value, it means data type is float 64. S1 dot shape. Shape is 5 comma, because it is the 1D like 1D array. We have 5 elements. It means I will display as a tuple 5 comma. Next is S1 dot n bytes. N bytes means number of total bytes it has taken. Total bytes taken by the series is 40. How it comes? We have 5 values and one value is taking 8 byte space because the data type is float 64, and one float data take the 8 bytes. It means I am getting 5 into 4, 8 equal to 40. Okay. S1 dot size means number of elements in the series object. Number of elements the series object is 5. This is the size. Has NaNs, this will display true or false. If this series contain NaN values, it means I am getting true value. If no NaN is there, no missing value is there, I am getting false. S1 dot empty. S1 dot empty will display this will display true if the series is empty. If I have created the empty series with no data value, then I will get true. Otherwise, if any one value is there, any one value is there in the series, then empty function will return me false. Okay, these are all my functions or attributes which I have discussed for the series. Now this is uh, almost finished. We have the series topic. See you soon in the next video. Okay, thank you.